Hi, I'm Gus Kaiser, and this is my presentation on the La Mancha acid rain research project that I have been working on with Professor John Call and fellow student Dao Wang since last June. It is the goal of our project to identify local and non-local pollution emission sources that may be causing acid rain deposition at the La Mancha site in Mexico. My portion of the project focus on identifying local pollution emission sources through the process of identifying meteorological phenomena that may be aiding in the transport of those pollutions towards the La Mancha site. Just to set the scene, the La Mancha site is located along the Gulf of Mexico in the state of Veracruz, about 70 kilometers northwest of the city of Veracruz. It's also worth noting that the data I'm using comes from the port of Veracruz. I have hourly observations every 3 to 6 hours for 2016, 17, 18, and 19 that I used to conduct my analysis. One potential meteorological phenomenon we identified that could be contributing to the transport of local emission sources was a sea breeze circulation. Essentially, a sea breeze circulation is caused by the difference in heat capacity in land and water, with the heat capacity of land being much lower. This leads to a phenomenon where during the daytime hours, where you have heating from the sun, the land will warm up much quicker than the water, in this case the Gulf of Mexico. This creates rising air motion over the land, allowing the more dense and cool air from the Gulf of Mexico to blow easterly onto the land, and then conversely, overnight, as the land cools down much quicker than the water, you will have a shift in that wind direction from um, from the land towards the water. This graph represents the average wind speed and direction at each hour that I have data for over the past 4 years, so 2016 through 2019. And as we can see, there is a shift throughout the day from being a more northeasterly direction towards a more northwesterly direction. And just to clarify, the time is in UTC, so thinking about this with respect to local time, 9 through 15 UTC are about 3 a.m. through 9 a.m. So kind of the overnight and morning hours, and then 18Z through 6 UTC, that would be about noon through midnight, so the afternoon and evening hours. So this does make sense that during the daytime we do get heating, and then around noon there seems to be a switch in the wind speed from being directed from the land to the water to the water to the land. It's also just worth noting that overnight wind speeds are about 1 meter per second less than they are during the day. This is mostly due to mixing down from upper level winds, but also because the temperature gradient is reduced overnight. So with all that sea breeze knowledge, we can now step ahead and look at some of the rain event data. I have roughly 200 rain events spanning 2016 to 2018. So this chart here depicts the average wind direction for the rain events occurring in each one of the months. As we can see, during 11 out of the 12 months, there's a preference for the wind direction to be between 0 and 45 degrees, so a northwesterly direction. And then February may look like an outlier, however, with the wind direction being close to 360 degrees. That's really just a northwesterly direction, so it's not a huge variance. But we can see that there is a preference during a majority of the months for winds to be from the northeast and therefore from the Gulf of Mexico over the land. We can then do a similar exercise with some of the other meteorological variables I have. This here is a wind speed average per month for each one of those rain events. Wind speeds here in kilometers per hour. We can see that wind speeds during some of the summer months, June through August and September even, are a bit slower than during some of the other months. This potentially means that with slower wind speeds, systems with rain may be moving just a bit slower, allowing for a little more pollution deposition during some of those months than during some of the non-summer months. And then temperatures, because Mexico is a more tropical region, temperature variation is much less than we're used to here in Wisconsin. You can see there's not a huge variation throughout the year, with low temperature averages during rain events near 20 degrees and during the summer months highs in the mid to upper 20s Celsius. Dew points follow the similar trend, a bit drier in the winter months compared to the summer months, but we do see that similar trend where there's not a massive variation in dew point temperatures, but we do see the warmer summer months with slightly higher dew point temperatures. And then pressure, as we'd expect, cold air is more dense than warm air, so pressures are higher in the slightly colder months than they are during the summer months during each rain event. And we do a similar analysis, but this time instead of breaking it down by month, we break it down by season. So the way I defined the seasons is, instead of the traditional 4 seasons, because Mexico is a tropical climate, they more have a 2-season annual pattern with a dry season and a rainy season. I define the dry season as November to May, which is when 58 of the rain events used occurred, and I defined the rainy season as June to October, which is where a majority of the rain events occurred, 153 to be exact. You can see that during the rainy season, there's a slight preference to be a little more easterly. However, during both seasons, during rain events, the winds tend to be out of the northeast. Similarly, for wind speeds, we've got stronger wind speeds during that dry season than we do during the rainy season. Seasonal pressure comparison. Again, this does make sense with drier, cooler air being a bit more dense than the warmer, moist air during the rain events. And then a seasonal dew point comparison, we can see much drier, obviously, during the dry season compared to the rainy events during those seasons. And lastly, we can look at a seasonal temperature comparison for the rain events. Yes, during the summer rainy months, we do see warmer temperatures as expected compared to the dry winter season with a bit cooler temperatures. So with all of these meteorological variables, we are now looking ahead to what we will do to continue this research. Currently, we're working to define a set of parameters categorizing a sea breeze day. This will effectively give us a way to analyze what days the sea breeze was the main driver of the wind directions and what days there might be some other feature causing changes in wind direction. And then after doing this, we will be able to figure out what percentage of the time are these rain events being affected by that sea breeze, and when is it something else that we may need to be looking at. Thank you.